Hello everyone, welcome back to VMAC1114 Trigonometry. Today we'll be starting section 5.1. Before I start section 5.1, I would like to do a quick recall as let's see if you guys still remember one of the concepts in college algebra when we have two functions and the graph of those two functions they are symmetric about the line y equal x. And anyone remember how those two functions related if they are symmetric about the line y equal x? If they are symmetric about the line y equal x, actually those two functions they are inverse of one another. Okay, and we also learn in college algebra that if the function is inverse of one another, then the composition equal x, right? F composed to G and G composed to F equal x. Besides, we also know that if the function has inverse, it means that they must satisfy the horizontal line test. Okay, so in this section we'll be talking about inverse function of sine, cosine, and tangent, and let's see those function has really has inverse for the whole domain or not. Okay, so let's get started. Alright, so section 5.1 inverse sine, cosine, and tangent. Okay. Now, on the first Roman, let's talk about inverse sine. Okay. Now, we already learned what size function look like. It's gonna go up and down, right? And if you put a horizontal line test, you will see right away that the graph. The horizontal line is cutting sine function at more than 1 point. And if you cut the function, the graph is more than 1 point according to a horizontal line test, then it means sine function doesn't have inverse, right? It doesn't have inverse. Then how come in this class, in this course, we're talking about inverse sine? Well, think about that. The function doesn't have inverse or for the whole domain. The sine function doesn't have inverse for the whole domain, but think about if we go ahead and put a restriction, we just restrict a part of the domain, restrict the domain, and we just take a part of the domain, and we see if that we will be able to check the horizontal line test for that part only, and you will see that if you put a horizontal line test for a certain part of the domain of the sine function, it cut only 1 point. Okay, now let me start the inverse sine function by starting the parents of sine function, right? Everybody know the parents of sine function will be like this. Will be y equal to sine of x, right? Okay, y equal to fx equal to sine of x. In order to get the inverse function, we're gonna swap, right, between x and y and x. So we're gonna swap it. Okay. Then in order to get y, then we're gonna have check the inverse. All right. So this is the inverse notation for sine function. So this is equal to f of x. This is the inverse function of sine. Okay, sometimes we can write like this. We call it arcsine. Okay, arcsine of x or sine of negative raised to negative 1 of x is it is the same thing. They are inverse of sine function. Okay. Okay. Now I'm gonna go ahead and grab a part of the sine function only, and you will see that if we put a horizontal line test over there, it's satisfying. Okay, so let me grab it for you. So I think I'm gonna grab with this color. Okay. All right. So everybody know that a sine function, the period is 2 pi, so it's kind of going up and down like that, right? And going up like that and like that. So I'm gonna put the restriction, and the restriction I take is just negative from negative pi over 2 to pi over 2. Okay, and a is still 1. A is still 1. So a is a 1. Oops. Oh, I deleted. Let me draw that again. Okay, so a is 1 right over here, and negative 1 over here. Okay, so because this is pi over 2, this is pi right over here, so sine function is kind of going up like that, right? Okay, so we're gonna have something like that. Okay, 1 point here. So the sine function, if I put the restriction, it's gonna be something like this. Alright, it's gonna be something like that. Okay, now think about that. If we just have a part of the sine function, only this small curve right over here, and of course if we go ahead and put the horizontal line test over here, if I go ahead and apply the horizontal line test, it cut only 1 point. So it means that this curve right here on the part of the domain, you know, they have inverse. Okay, now based on this graph right here, this curve, we can find the domain over here. So the domain over here we go from negative pi over 2 to pi over 2 only. Okay, negative pi over 2 to pi over 2 only, and the range over here will go from negative 1 to 1. Okay, all right. Now I'm gonna go ahead and graph the inverse. Okay, to graph the inverse of this one. Okay, of this sine function here. So this is f of x equal to sine of x on negative pi over 2 to pi over 2 only. Okay, now I'm gonna graph the inverse. So I'm gonna put I'm gonna draw the line y equal x, right, and we're gonna put a reflection about that line, right? We're gonna put a reflection about that line, and you will see that a really interesting graph of the sine function. So so let me see. I'm going to use this one. So I'm going to go ahead and grab the inverse. Okay. So the concept of inverse function are that the domain of the inverse become the domain of the original function become the range of the inverse. So the range become the domain. So the domain of the inverse actually is go from negative 1 to 1, and the range will go from negative pi over 2 to pi over 2. Okay, negative pi over 2 to pi over 2. Okay. All right. Now I'm gonna draw the line y equal x. I'm gonna draw symmetrically about that line, and you will see that so this negative 1 over here. Okay, so this is 1 right here, negative 1 right over here. Okay, and this is negative pi over 2 here, and pi over 2 over here, and you will see that it's gonna go like this. Okay, so symmetric about this line, right? So just think about it. It's gonna kind of like that, right? Kind of like that. So it's gonna be something like this. There you go. It's gonna be something like that. Okay, let me draw that again. There you go. There you go, kind of that curve right there. So this will be the graph of the inverse of sine. So this is f of x equal to inverse of sine of x. Okay. And as I already said at the beginning, I said that if the function is inverse of one another, it means that when they compose to one another, it turn out to be x, right? So that's why we have a relation between the sine and the inverse of sine. So I'm gonna put next I'm gonna talk about the identity of those relations. So I'm gonna have this. So identity. So let me see. Let me use this one. Okay. So the first identity that if we have a sine of -1 of x, this is turned out to be x, and then x over here is going to be x will be the output of the sine. So the output of the sine, which is the range, so it will be x will be from -1 to 1 in this case, -1 to 1, -1 to 1, and inverse of sine of x also turn out to be x, and the x over here could be the output of inverse, so the output could be the range. So over here the x over here must be from -pi/2 included to pi/2. Okay. Now let me start with the first example. Let's see how we're gonna apply the inverse function to evaluate. Now I want you to find inverse of a square root of 3/2. Okay. That's it. So you know right away that if we take sine of pi/3, it turned out to be a square root of 3/2. But I want to show some work over here, okay? Because if we go ahead and use the table I showed you before, you using a unit circle, and we know the sine of pi/3 give you square root of 3/2. But remember that there's so many angles give you, when you take sine, give you square root of 3/2. So we gotta really show the work over here, okay? So first of all, I'm gonna let let me see which one. I'm gonna let x let x equal to sine. Okay, I'm sorry. I'm gonna let sine of x. So let me say let y equal to inverse, because we want to find y, inverse of square root of 3/2. Then from here we're gonna have sine of y equals square root of 3/2. Okay, and this is positive, and side positive we know the quadrant 1 and 2, right? Quadrant 1 and 2. And we want to find y. Y is the output of the inverse. The output of the inverse over here. So y and y is belong to -pi/2 to pi/2, which is -pi/2 to pi/2. Think about that. We have over here. We have the unit circle. This is pi/2 over here. This is -pi/2 over here. So if you go from -pi/2 to pi/2, right? You go from this direction, right? We go from negative to positive, okay? So this is going to be quadrant 4 and quadrant 1. So we're going to have quadrant 1 and 4, right? So from these two information, the quadrant we're looking at will be quadrant 1. It'll be quadrant 1. Okay, and now we can go ahead and draw the reference triangle, quadrant 1. Okay, quadrant 1. So sine will be opposite over hypotenuse. Opposite over hypotenuse. So this is y right here. Okay. So over here you're gonna have it's 1 right over here, right? So this is 2 and this is 1 is square root of 3. So we know right over here this is this be a 60 degree. I think yeah, the picture is not nice. Let me draw it again. let me draw it against it. So I'm going to have something like this. There you go, square root of 3, 1, and this is 2. So the angle over here, you know, right, which is the first quadrant, right? So this must be 60 degrees. So y over here. So y must be pi over 3, right? Pi over 3, 60 degree over there. Because this is 2, this is square root of 3, and this is 1 over here, right? So this is like this is 1 over here. This is 1, 2. So this is 60, and this is must be 30. Okay, and this must be 30. All right. So the y could be pi over 3. All right. First quadrant. Actually, if you use the table, you know right away it's pi over 3 though, because it's the reason we show work over here, because we just need to know the work, the first quadrant. You know, I mean, when you get used to, you know right away it's pi over 3. But what if I should give you something like this on a test? I want you to show some work. Okay, so this is the work. Now let me give you another example. Example number 2. I want to find sine, inverse sine of -2, of 2. I'm sorry. All right, I want to find the inverse. Okay, so you mean I want to find the output, right? The out. So over here, I'm gonna have y equal sine of y equal 2, right? Sine of y equal 2. Okay, sine of y equal 2. And so think about it. We have sine of y equal 2. Okay, and sine of y, the domain is negative pi over 2 and pi over 2. Okay, domain is negative pi over 2 to the domain is negative pi over 2 and pi over 2, and the range, right? 2 is the range. 2 is the range of y, right? 2 is the range of y. So in this case, 2 is greater than 1. 2 is greater than. Okay, because this 2 is the output, right? The output is range, and 2 is greater than 1. Okay, since 2 is greater than 1, so it is out of the range. And if it is out of the range, then we cannot find the inverse, right? You cannot find the inverse. Okay, or you can think like this. This is the input of the inverse. The input of the inverse is 2. Okay, the input of the inverse is 2, and the input is the domain. It's also greater than 1. So that's why over here the answer would be does not exist. D and E, because the input of the inverse is out of the interval right here. It's not in the -1 and 1, so it is not working. Okay. Alright, how about this one? Example 3. Sine inverse of -1. Well, usually you have to show some work over here, but I'm just do a kind of fast over here. If you look at ahead, you go ahead and look at the unit circle. Excuse me. So this is sine right here. Okay, and this is cosine, and this is 1 right here, and this is -1, right? And they ask you for the degree when sine equal negative. Inverse of -1. So it means that over here I can write it as this, right? And sine of y equal -1. So what is the degree, right? What is the degree of it? What is the radian over here? So it could be 270, or it could be 3 pi over 2, right? 3 pi over 2, or it could be negative pi over 2. Okay, it could be negative pi over 2, or 3 pi over 2. Okay, 3 pi over 2. Okay, 3 pi over 2 and negative pi over 2. We gotta see which one. We gotta see which one. Okay, so again, in this case, we gotta see that because sine over here is -1, so it's -1, so it will be quadrant. Over here we're gonna have quadrant 2, 3, and 4, right? 3 and 4, and the inverse, which is the y over here. Y must be y, and y must be negative pi over 2 to pi over 2. So it means that it must be quadrant 1 and 4, right? So the quadrant, it will be quadrant 4. Alright. And this is quadrant 4, so it's gonna be so the y over here, will be negative pi over 2. Okay, negative pi over 2. Actually, it's not a really big deal, to be honest with you, because it's right over here. This is quadrantal angle, so you don't have to be honest. You don't. If you go ahead and put a 3 pi over 2, I'll take it. You know, it doesn't have to be negative pi over 2. I just want to show some work, that's all. But it doesn't have to be negative pi over 2. Could be 3 pi over 2. And there's so many angles, to be honest with you. So many angles give you. It could be think about it. If you go one revolution and you go another one, you go back to this one. So it could be also. Okay, it could be also. It's also over here in the first example. It doesn't have to be in the pi over 3 because when you think about it, it's the first quadrant. The first quadrant over here, you go around one more revolution, you go back to the first quadrant. So it could be many angles. Just pick one, okay? Just pick one, and because over here sine is positive, so as long as sine positive, as long as sine positive first quadrant, I'm sure that that will be fine. Okay, so it could be that doesn't have to be pi over 3 to be honest with you. Okay, same thing over here, because over here a very special case. It could be because this is right at quadrantal position, so right over here, so it could be negative pi over 2. Okay, or 3 pi over 2. Okay, or 2 pi plus 3 pi over 2. This is so many of them. Okay. But the reason I write a lot of here, I just want to for you to understand a little bit, you know. But actually, you can get the correct answer right away. Okay. Alright. Unless over here they put a restriction. They say that okay, it must be in a certain angle. Then in that case, you're gonna pick the answer differently. So whatever over here, they say that the angle must be from 0 to 2 pi, right? The angle must be from 0 to 2 pi. So you have to pick 3 pi over 2. Okay, but if you pick negative pi over 2, you'll be wrong, right? Because it's not from 0 to 2 pi. But if the question asks you, it must be from negative 2 pi to 0. Okay, then your answer must be negative pi over 2 in order to get it correctly. Other than that, it did not. If it doesn't specify the restriction, the interval, then it doesn't matter. You can pick negative pi over 2 as the answer, or 3 pi over 2. It's be the same thing. Okay, it's be the same thing. Okay. Now let me give you another one. Okay, example number 4 over here. Alright, so we want to find the inverse of the sine 1 over 2 equal. Alright. So if you look at it, you want to find the y over here. So you want to find y. Okay, you want to find y. And y is the output, right? Y is the output of the inverse, and the output of the inverse is from negative pi over 2 to pi over 2. Right? Output of the inverse is from negative pi over 2 to pi over 2. Y must be from negative pi over 2 to pi over 2. And 1 over 2 over here. 1 over 2 over here is, I believe, is less than pi over 2. Negative pi over 2 less than equal to 1 over 2 less than equal to pi over 2. Pi over 2 is 3.14 divided by 2. So of course it must be greater than 1 over 2. Okay, so that's why over here the answer in this case, so inverse of sine of x, we turn out of the sine of 1 over 2x will be 1 over 2. Alright. Okay. Example number 5. Find cosine of inverse of 2 over 3. Okay. Alright, so let's see how we do it. First of all, we're gonna let cosine, let y equal, equals inverse of 2 over 3. So you're gonna have sine of y equal 2 over 3, which is positive, and this is imply this is quadrant 1 and 2. Now y is the output of the inverse. The output of the inverse will be the output of the inverse will be the input of the original. So it will be y will be from negative pi over 2 to pi over 2. Okay. So it will be in quadrant 4 and 1. So the final quadrant 1. Alright. So I do the quadrant 1, so go ahead and draw the triangle. Okay. Two, 3 over here. So this will be square root of 5. Okay. And so it will be quadrant 1. Quadrant 1, when you take cosine, quadrant 1 cosine, right? So it will be cosine of y. So cosine, okay, cosine of y. So this is y right here. We quadrant 1 cosine positive, square root of 5 over 3. Okay. And that's why this is going to be equal to cosine. This implies cosine inverse of 2 over 3 equals square root of 5 over 3, because it's positive, cosine positive in quadrant 1. Okay. So over here, the purpose of quadrant is clear, because it helps you to determine is it positive or negative square root of 5 you're gonna take. But I mean, over here actually you don't need it, to be honest with you, because actually if I go ahead and add 2 pi, it's still in quadrant 1 though. But quadrant 1 is is good enough in order to get the answer. Okay, so I just want to show some work over here. That's all. Over here is much better, because quadrant 1 tell you that this is plus or minus, okay, for the cosine. Okay. All right. Last one. square root of phi. Okay, answer. Okay, let y equals to inverse of -1 over square root of 3. So sine of y will be -1 over square root of 3, and it's less than 0, so this will be quadrant 3 and 4. And again, y is in quadrant 1 and 4. So the final answer will be quadrant 4. Okay, now go ahead and draw the picture. Quadrant 4. So we're gonna have something like this. Side will be opposite. Okay. So this will be 2, right? V2. Alright. So y right here. And in quadrant 4, so tangent will be negative. So tangent of inverse of -1 over square root of phi says this will be -1 over 2. Okay, -1 over 2, because tangent in quadrant 4 must be negative. Okay. All right. So that's all for the inverse tangent. Now let's jump to another function. This is the inverse cosine. Okay, I'm sorry, that's the inverse sine. I said inverse tangent. Then we jump to inverse cosine. Okay, so in the second part of our lecture, we will be talking about cosine, inverse cosine. And before we start about inverse cosine, let's talk about the graph of the cosine function. You know that the graph of the cosine function is kind of similar to the sine function, except for the part that the graph of the cosine function is nothing but you move the graph of the sine function to the left by pi over 4, right? So think about that. What does it mean by that? It means that if we go ahead and apply the horizontal line test, the graph of the cosine function will cut the horizontal line at more than 1 point. So there's no way that cosine function has an inverse for the whole domain. No way. However, if we go ahead and put a restriction on certain part of the domain, they do have inverse. Okay, they do have inverse. And let's see what is the graph of the inverse of cosine look like. Okay, so on the second part, let's talk about inverse cosine. Okay. Alright, so everybody know that if we have y equal cosine of x, this is the parents function of the cosine, then in order to find inverse, we swap them, kind of the same thing as we had for the sine, for the inverse sine. So over here we can get y by inverse of sine or inverse of cosine, or we can call the arc cosine, kind of the same thing. Okay. And now if I go ahead and put a restriction on certain part of the domain, over here I'm gonna take a part of the domain, so I just take from 0 to pi only, just a part of one period. So we have something like this. See, so we have okay, so this is the graph of the cosine from 0 to pi. Okay, so this is pi over here, this is x over here, and this is y over here. So it's going to be something like this. So if the amplitude is still 1, -1, so this is be pi over 2. So it's going to be something like this. There you go. Alright. So think about it, if we go ahead and apply the horizontal line test over here, it cut only one point, right? So it means that the graph, the cosine, will have inverse on the domain from 0 to pi. So the domain over here will be 0 to pi, and the range here will be is still from -1 to 1. All right, now let's graph the inverse. So let's just go ahead and flip it over. So just think about it, you're gonna flip it over this line. So we kind of this go down here and this kind of go up here. So the domain become the range and the range become domain. So the graph of the inverse of the cosine could be something like this. So this could be so the range become the domain. So this will be -1 and 1 right here. So pi is going to be all the way over here. Okay, so we're gonna have something kind of similar like to this one. Okay, so over here will be pi over 2. So it's gonna have something like that. There you go. Gonna be something like that. Okay, it'll be something like that. All right. So it'll be y right here, and then it's be x over here. So this will be the inverse cosine. Okay, and this is just cosine. Okay, so think about that. If we had a graph like this, so the domain become range, range become domain. So the domain over here now is -1 to 1, and the range now becomes 0 to pi, 0 to pi. So last time we remember the inverse, the range is from -pi over 2 to pi over 2, right? That's the range, -pi over 2 to pi over 2. But now the range is from 0 to pi. Okay. And they also have the identity. Just tell you the relation between the inverse cosine and the cosine function. So the identity. So we're gonna have cosine of the cosine negative x. It could be equal to x. So this is the x could be the output of the cosine. The output of the cosine will be the range. So x, make sure over here x will be from -1 to 1. But however, if we take the inverse cosine of the cosine of x, it's also turned out to be x, but x in this case will be the output of the inverse cosine, which is the range of cosine will be here, will be from 0 to x to pi. Okay. All right. Let's start with our first example. Okay. Let's see. So I'm gonna have inverse cosine. Find inverse cosine of negative square root of 2, negative square root of 2 over 2. So okay, so let's see how we do this. So I'm gonna let y equal to that, because that's what we're looking for. Then we're gonna have cosine of y equal to negative square root of 2 over 2, which is less than 0. So we're gonna have quadrant negative equal to 2 and 3. Okay. All right, and we also know that y is the output of the inverse cosine. So the y, we know that since y is belong to 0 to pi, so 0 to pi will be quadrant 1 and 2. So from here, so we will have quadrant 2 and 3. It's 2 and 3. So we're gonna have quadrant 2 as the final. It will be quadrant 2. Okay, so it equals quadrant 2, so we're gonna have something like this. Alright, so we're gonna have cosine will be cosine y opposite adjacent over hypotenuse. Okay, so the angle over here equals to quadrant 2, so that this is the angle y right over here. This angle y right here, not this one. Okay, this is the reference one. The reason last time we have this the same because it's the first quadrant. Okay, so this is the second quadrant, so this is the y over here, and this angle over here will be 45, so this is the pi over 4 over here, because this is square root of 2 and this is 2, so this one must be square root of 2, right? Square root of 2. So this is 45, 90, 45, so this must be pi over 4. So angle y over here must be pi minus pi over 4. Will be 3 pi over 4. There you go, 3 pi over 4 as the final answer for angle y. Okay. Of course, again, there's so many other angle that give you negative square root of 2 over 2. But because this is a second quadrant, so there's only one of them over here. We can get another one right over here, which is second quadrant negative, but this one doesn't give you square root of 2 over 2. It give you it's the third quadrant. I'm sorry, the third quadrant also give you for example over here you have if you have pi plus pi over 4, which is 5 pi over 4, so give you negative square root of 2 over 2. But the thing is that this is in that case it would be quadrant 3, not a quadrant 2. Okay, so last time we have the sign and a little bit different from this one, so it still depends on I mean last time it's the sign, and over here we also have another case when this quadrant 1, right? So think about if you have quadrant 1, size is positive. We also have another case, pi minus pi over 3. So pi minus pi over 3, which also give you 2 pi over 3, give you give you sine positive also, right? Pi minus pi over 3 is pi over 3, 2 pi over 3. Yeah, it also give you the same answer. However, in that case, it would be a quadrant 2, and this is quadrant 1. Okay, so must be pi over 3. Okay. So yes, it affects some way somehow, but not all, because think about it, if you go ahead and do 2 pi, it still give you. So there's so many angle to give you pi over 3 though. Many. I have to say that. Okay, same thing over here. If you go ahead and go do 2 pi more another revolution, it's also give you go back to angle quadrant 2, and you see that so many angle give you negative square root of 2 over 2, not just 1. Okay. But this is but there's another one give you also negative square root of 2 over 2, but it's not in second quadrant. So I mean, if they just ask you for one value, then one angle, then that's fine. Okay, and just pick the one in quadrant 2 to be fine. Okay. Now let's do another one. Example 2. So over here I'm gonna calculate something simpler. Okay, so this one we know that it's gonna be give you 0.7, but if it give you 0.7, so 0.7 could be the output, right, of the cosine, and the output, which is the range, will be from -1 to 1. So yes, so 0.7 is between 0, 1 and 1, so that's why cosine of 0.7 give you 0.7. Okay. Now how about this one, example 3. What if I want to calculate sine of inverse of -1/3? Okay. Now first of all, let y equal to cosine inverse of -1/3. So from here we get out y cosine of y equal -1/3, which is less than 0. So it will be quadrant 2 and 3. Okay. And we also know that y will be belong to 0 to pi, because it's the output, which is quadrant 1 and 2. So finally, the final quadrant will be quadrant 2. Okay, with quadrant 2. So quadrant 2 side will be positive. As long as you get the final answer positive, you got it correctly. Okay, so go ahead and draw the picture. Alright, so cosine will be cosine here. Okay, will be sorry, here could be a j, could be adjacent over hypotenuse. So this will be 2 square root of 2. So sine of y, so sine of y in this case, it will be sine will be opposite. It will be quadrant 2, so tangent will be negative. So we get a negative square root of 2 over 3. Right, quadrant 2, right? Quadrant 2 side positive. I'm sorry, I always want to do side positive. All right, which is equal to sine of cosine inverse -1/3. Now, all right, quadrant 2 side positive. This is sine. Okay, this side positive. Okay. All right. Now let's do another one, and this one is a combination of what we also learned last time. It's a combination of inverse sine, inverse cosine. Cosine of sine 3/5 minus inverse cosine 4/5. Alright, so 3/5 is the input of the inverse sine, and 4/5 is the input of the inverse cosine. Okay, so in order to do this, we have to apply the formula cosine of a minus b. Alright, cosine of a minus b. Remember this formula, it could be cosine a, cosine b plus sine a, sine b. So from here, this is your a, this is your b. So we would have cosine a, okay, cosine a, cosine b, okay, plus sine a, okay, sine b. Alright, that's a big one. Now we're gonna do one by one. So for this one we can get it because this should be give you 4/5, right? Because 4/5 is less than between -1 and 1. So this one is gonna end up with something like this. This is give you 4/5. Inverse this is the output. The output also 3/5 between -1 and 1. So this is to give you 3/5. Now we just need to calculate the sine of the inverse and the cosine of the inverse sine. Alright, so we need to calculate this and this. So this is where you need to show some work with the picture. Okay, this is the same thing as we did last time. So so I'm gonna let y equal to inverse sine of 3 over 5. So from here we will have a sine of y equal 3 over 5, which is greater than 0, so it will be quadrant 1 and 2. Okay, and we know we have y will be from 0 to pi, so will be in quadrant 1 and also 1 and oh crap, sine positive quadrant 1 and 2, and inverse of sine. Oh, inverse. This is inverse of sine. So we negative pi over 2 to pi. So it will be negative pi over 2 to pi over 2. So it will be quadrant negative pi over 2 to power is right. Yeah, negative pi over 2 to pi over 2. So it will be quadrant 4 and 1. So from here the quadrant, the final quadrant will be quadrant 1. Okay, and quadrant 1, so we're gonna have something like this. Sine 3 over. Okay, now we're gonna take this will be 4. Okay, so we here cosine will be cosine y will be 4 over 5, and which is quadrant 1, so cosine positive. Okay, now the same thing over here. You know what, I'm gonna call this a. There you go. So a equal the same thing over here. I'm gonna calculate it. So let's y equal to inverse cosine of 4 over 5. So cosine of y equal to 4 over 5 positive, so the quadrant 1 and 4 equal cosine positive, and y over here belong to 0 to pi, so it will be quadrant 1 and 2. Okay, so the final quadrant will be quadrant 1. Okay, also quadrant 1. 1 and 4. Yep, so quadrant 1, so we're gonna have the picture like this. So it will be cosine. This is 5, so this will be 3. Now we're gonna take sine. So sine of y was sine will be positive, equal quadrant sine will be 3 over 5. So from here we get the final answer. My a will be this will be 4 over 5 times 4 over 5 plus 3 over 5 plus times 3 over 5 will be 16 over 25 plus 9 over 25, which is 1. Here you go. Yeah, it's not really that bad, huh? Alright. Good. Okay. Okay, so I mean, on the test we're gonna have something like this. So this is what you're supposed to show me on the test. Okay, if you look at the sample test, you would see something similar to this. I mean, if we have time, we will be working more. We're gonna have we'll be practicing more on this type of question. Okay. Okay, so on the last part of our lecture today, we'll be talking about inverse tangent, And let's see if we need to put a restriction on a part of the period or the domain in order for the tangent function has inverse or not. Okay, so let's get started. So this is part 3, so I'm going to put part 3 here. Inverse tangent. Okay, again we're gonna start with tangent function y equal to fx equal to tangent of x, and we swap it, so x equal to tangent of y, and now y equal to inverse tangent of x, which is arctangent of x. Okay. A good thing about the inverse tangent is that it can be derived based on the whole period of the tangent. So it means that we don't have to put some restriction on the domain. Of course, if you consider a whole domain, tangent doesn't have inverse, but we can consider a whole period. So let's grab the whole period of tangent function. So let's start with this one. Okay. So this. So I'm gonna draw one period only. So which is over here will be pi over 2, and over here will be negative pi over 2. So we're gonna have two vertical asymptote, and this is what the tangent function look like, right? So it's gonna go like that and go like this. And if you look at it one period, so we see the domain go from negative pi over 2 to pi over 2, not included, and the range will be go from negative infinity to positive infinity. So if you apply the horizontal line test, you see that there's only one intersection point. Now I'm going to go ahead and draw the inverse of this one. Okay, so this is tangent of x for one period only. Now I'm going to draw the inverse one. This is so the domain become range. So this will become range. Range will be go from negative pi over 2 to pi over 2. Okay, which is right over here. Okay, it's negative pi over 2 here, and pi over 2 over here, and range become domain, so the domain become a negative infinity to positive infinity. So this is the inverse tangent. It looks like the cube root graph of the cube root function. So it's gonna be something like this. Okay, let me erase it. So it's gonna be something like this, curving up, and a curve like that. So this is inverse tangent, or arctangent, kind of same thing. Do they have the relation? Yes, they also have the relation. So I'm going to put the identity here between the tangent and the inverse tangent. Okay, identity. So over here we also have a tangent of inverse tangent of x could be equal to x. And this is the output, so this could be for all real number. Okay, and the second one is inverse tangent of x equal x, but now will be from negative pi over 2 to pi over 2, not included the endpoint. Okay, not included the endpoint. Alright, now let's start with our first example. I want you to find inverse tangent of negative 1 over square root of 3. So again, let me see. You can get the answer right away, though. You can get the negative square root of 3 over 3, so it will be negative pi over 6. That will be the answer. Okay, that could be the answer, because you can, because this is a very simple one. You don't have to do anything about, but I'm gonna show you some step anyway. So again, we're gonna let this equal to this. Then we're gonna have tangent of y equal to negative square root of 3, which is less than 0. So it will be quadrant tangent will be 2 and 4. And the inverse tangent, the domain of inverse tangent, it could be domain of inverse, no, the range of inverse tangent could be from negative pi over 2 to pi over 2, which is quadrant 1 and 4. So from here we're gonna get the final quadrant. Final quadrant could be quadrant 4. Okay, so we're gonna have something like this, right? Quadrant 4, tangent negative. So we're gonna have something like this. So it could be like that. So it could be negative 1 over square root of 3. Okay, so this is 1 is the square root of 3. So this one must be what? 1 square root of 3. So this one must be 30 degree, right? So pi over y over here will be pi over 6. Negative pi over 6, because quadrant 4 tangent will be negative pi over 6. Okay. There's another quadrant. So the tangent is negative. It was over here, right over here, quadrant 2. So, but because we want a quadrant 4, so we're not gonna do quadrant 2. Okay. If you do quadrant 2, could be pi minus pi over 6. It could be 5 pi over 6. So in that case, we could give you negative 1 over square root of 3. But again, we're gonna do quadrant 4. And again, I already told you that there's so many angle that give you negative 1 over square root of 3 anyway. Okay, include this one. So pi plus, this is pi over 6, right? So this is pi over 3 over here. So it will be pi over 2 here. So pi plus pi over 2 plus pi over 6. But this one, if you take this one, it's give you positive 1, not negative 1. Okay, so you gotta go backward in order to get negative. Well, let me see. Hold on. This one pi. Yeah, this one also negative 1. I'm sorry. This is also negative 1. Okay, this is also give you negative value because this quadrant is still quadrant 4. Okay, so the many angle give you the same value, negative 1 over square root of 3. Not just one angle, negative pi over 6. Okay, could be 11 pi over 6 in there. Positive 11 pi over 6. It still give you negative 1 over square root of 3. Okay. All right. Number 2. Fine. Tangent of inverse tangent of 35. Okay. So this the answer over here will be easy because it will be 35, and this will be output. Will be the range of tangent. The range of it will be negative infinity to positive infinity. So yes, so the answer over here will be 35. Okay, because 35 it belongs to negative infinity to positive infinity, which is the domain. It will be the range. Okay, it's right over here. Okay. Now I'm gonna do this one. So I'm gonna do cosine phi secant of inverse tangent of square root of 3, for example. Okay. So answer, and let y equal to that. So it's kind of same thing, you see that? So it will be tangent of y equals square root of 3, which is greater than 0, tangent positive, so the quadrant 1 and 3. Okay, and now inverse tangent y will be from negative pi over 2 to pi over 2. The output, which is the range. Okay. Okay, then we're gonna have quadrant 1 and 4. So the final quadrant will be quadrant 1. Okay. So we're gonna have quadrant 1, so it'll be over here. So we have tangent will be square root of 3, 1. So this y right here. So this one give you square with 2. Right. Now we're gonna take secant, so we're gonna take cosine. So cosine of y, cosine go back, and over here cosine could be positive, will be 1 over 2. So secant of inverse tangent of square root of 3 will be 2, because secant is 1 over cosine. Okay, so it will be positive 2. All right. Example 3. Example 4. Find b value, which is equal to cosine inverse tangent of 1 plus inverse 1 over 3. Okay. Alright, first of all, cosine, we need to apply the formula cosine of a plus b. So be cosine a cosine a cosine b minus sine a sine b. Sine a sine b. Okay. So let's see which one we can evaluate, which one we cannot. Look like that we gotta calculate all of them except for this one. So this we're gonna have cosine inverse tangent of -1, cosine inverse 1 of 1/3, and sine of inverse tangent of 1. This one give you 1 over 3 because 1 over 3 between -1 and 1 as the output. So this is 1 over 3. Now we gotta calculate this. So we let y equals inverse tangent of 1. So tangent of y equal 1 greater than 0. which is quadrant. Quadrant. Oh, we don't need to because it's a. Oh, let me see. Yeah, we don't have to because this one we can get right away. Actually, this is give you 45 degrees power 4, but I just want to write it. Quadrant 1 and 3, and inverse tangent. Okay, inverse tangent is inverse tangent is between negative power 2 and power 2, which is in quadrant 4 and 1. So we're gonna end up with quadrant 1. Quadrant 1. So we're gonna have a picture like this. Okay. So this is 1 1. So this is square root of 2. So this is 45 degree actually. So so we're gonna take cosine. So it's cosine y. So cosine of y, which is cosine of y will be cosine of tangent inverse tangent 1 will be positive with 1 over square root of 2 with square root of 2 over 2. Okay, that's for the first part. Now we're gonna do for this also. So over here we're gonna let y equal to inverse 1 over 3. So sine of y equal to 1 over 3. So it will be quadrant 1 and 2. Alright, inverse sine. Inverse sine is from negative power 2 to power 2. So quadrant 4, 1 and 4. So it is quadrant 1. Okay, draw that. Okay, so sine will be 1 3. So this one will be 2 square root of 2. So we want to take sine. Sine in this case is also positive. So sine of y will be tangent is sine. Oh, I think I got something. We're gonna take cosine. I'm sorry. So, cosine. Cosine positive 2 square root of 2 over 3. Okay, let's cosine of y. Now similar we can do this one. Okay, but now we're gonna do sine. So it will be also positive. So this is also square root of 2 over 2. So finally we're gonna have b equal to square root of 2 over 2. So times 2 square root of 2 over 3 minus square root of 2 over 2 times 1 over 3. Okay, so answer will be 2 over 3 minus square root of 2 over 6, which is 4 minus square root of 2 over 6. There you go. That's final answer. Okay. So on the test, you guys have to show all the work like that, okay? With the picture like this, okay, with the picture Okay, and include a picture for this one. Okay, but this one I don't have enough space, so I did not show up for this, but on the test you have to show up for this. Okay. Okay, so I guess I'm gonna stop the inverse tangent over here. Then we have time. Then I'm gonna give you more practice problem in class. Okay. I will be seeing you next time on the new section. Bye bye.